Okay, so let's go ahead and get started again. And this time, when we come back, we're going to talk about subroutines again, but we won't talk about just subroutines anymore. In other words, we'll try to introduce additional concepts that are related to subroutines. And the first thing we'll do is to talk about why global variables, which are the only type of variables that we have used up to this point, are not really exactly a good thing to use. Okay, because global variables, as the name implies, are global. Okay, you can access those variables anywhere you want in the program, inside a subroutine, outside of a subroutine, anywhere at all. Okay, anywhere you can access those variables. So we'll start with something like this. Okay, we'll define sub, and we'll say increment x by 3. Okay. But instead of saying x equals x plus 1, x equals x plus 1, x equals x plus 1, well, let's see, with this class I can change this so that we can increment x by k. Okay, k is a constant or another variable. So the way we do it is fairly easy. We can use a loop to do it. I gets initialized to 0 while I is less than k, do. And then inside we can have x gets x plus 1, I gets I plus 1, and while, and define sub. So this is a very slow and not so smart way to add k to x, but it should work, right? It's just not very smart, not very efficient. Is that okay so far? Because we are going through this loop exactly k iterations. Because I was initialized to 0, every time we go through this loop, I gets incremented by 1. And we get out when I is not less than k anymore. So as long as k is a positive number, this should work. Oh, you guys convinced that this is the same as getting x to x plus k? So then we'll define the other subroutine as computing increment x k squared. So this time what we'll do is we'll set up something like this. I gets 0 while I is less than k, do. But instead of incrementing x by 1, we invoke increment xk. I gets I plus 1. And define sub, and loop first, and while, and define sub. This looks kind of too complicated. Let me just simplify. Because the whole point is not the calculation. The whole point is why global variables are not really good to use. So we'll change this a little bit. I'll just change the nature of the code a little bit here. Okay, we'll just print lotto, okay, 3 times. Okay. To print lotto 3 times, there are quite a few ways to do it. I'll do it in a loop. While I is less than 3, do print lotto. I gets I plus 1, and while, and define sub. Are you guys convinced that this subroutine will print lotto exactly 3 times? Okay. It should be fairly obvious now that this loop will do something exactly 3 times because I gets initialized to 0 and I gets incremented by 1 for each iteration. So the question is, how many iterations does it need in order to get to 3? Well, it will take exactly 3 iterations. So the next one, I would say, okay, print lotto 8, 9 times, okay? And I'll use the same approach. I gets 0, while I is less than 3, do, invoke, print lotto 3 times. I gets I plus 1, and while, and define sub. Just so that we don't need to spend all day long, tracking down this program, I'll just make it a little bit smaller. So we'll use 2 times here and 4 times over here. But it's the same approach, okay? All I'm doing here is just to reduce the number of iterations so that we don't have to spend all day long here just to track down this program. But the approach is the same. Okay. Does it seem to make sense? If this particular subroutine is going to print lotto exactly twice, and I'm going to invoke it twice here, then we should end up with 4 lottos that we are printing. Is that right? Because 2 times 2 is 4. Except this program doesn't work the way it's supposed to. Which is the whole point. The whole point is it doesn't work. Now why is it not working? Let's try to figure that out. So we have a program like this, and let me save the file first, and we'll save the file with a name that is indicative of the point that I'm making. Global variables are evil. Okay. All right. So now we go to the second sheet to track down what this program is going to do. Even though it seems obvious what it should do, it is not going to do that. We have comments because we do have 2 loops here. We have line number, the usual. We have I as a global variable because we haven't talked about anything that are not global variables. So all variables up to this point they're all global. And the precondition is I don't need to know anything about I because it will be initialized later on. What is the first line that is outside of the definition of any subroutines? Line 15. Okay, line 15 is the only line that is outside of the definition of a subroutine. And what does it do? It invokes a particular subroutine called print lotto 4 times. And as usual, by this time we should know the procedure already. We allocate the leftmost available column. Remember where we're supposed to go back to, and then we continue on the first line in the subroutine that we're invoking, which in this case is line 9. Line 9 is going to initialize I to 0. Then we go to line 10. We have to evaluate the condition. I is less than 2 is true because 0 is less than 2. Then we go into the loop. We go to line 11. Line 11 is invoke print lotto 2 times. Okay, fine. So we'll allocate the leftmost available column, which in this case is column E. We label it as return line number, and then we have to indicate which line to go back to, which in this case is line 12, because line 12 logically follows line 11. Then we continue execution inside the subroutine. The subroutine starts with line 2, so that's where we'll start. And line 2 says we want to initialize I to 0. Right here, okay, even though you may not know that something is definitely wrong, it should be something in your mind going like, this doesn't feel right, because we are initializing the same I again. Okay? But it seems okay at this point because it was 0 and we're just reinitializing it to 0, so it's not doing any harm at this point. But something should be kind of like bothering you in your mind because it just doesn't feel right. Then we go to line 3, and line 3 is doing I is less than 2 is true. We go to line 4. Finally, we actually print the word lotto. Okay, and then we go to line 5, which adds 1 to I. I goes from 0 to 1. Then we go back to line 3 again. Okay, I, which is 1 at this point, is less than 2 is true. We go to line 4 again. It prints another lotto. And then we go to line 5, which increments I 1 more time, so it is now 2. We go back to line 3. 2 is less than 2 is false, so we get out of that loop. We go to line 7. Line 7 is end define sub, which means we have to look up the rightmost return line number, which is column E in this case. It tells us we have to go to line 12, and this is where we go, and then we can deallocate this column because it's no longer in use. And in line 12 is going to add I. It's going to add 1 to I again. Now at this time, alarm should be blaring in your head, because oh, hold on a second here, we have just invoked print lotto exactly once. How come I is now 3? Well, it's because it's the same I. Okay, we are using the same variable in print lotto 4 times and print lotto twice. It's the same variable. So if one variable, if one subroutine is changing it, the other one will see the changed variable because they are exactly the same thing. So when on line 12, when I add 1 to I, it's going from 2 to 3. Then we go back to the beginning of this loop on line 10, and line 10 is just asking, is I less than 2? Nope, it is not, because I is now 3, 3 is less than 2 is false. So we get out of the loop, we end up on line 14. Line 14 is n-defined sub for print lotto 4 times. We have to do the same thing. We have to look up the rightmost return line number, which is column D this time. Okay, we go to post, next, and then we deallocate column D. This is what we get. How many times did we actually print lotto? Twice, and not 4 times. Even though, according to the code, it seemed obvious that it should have printed lotto 4 times. Where's my problem?
Overwriting I.
The problem is I only have one I, okay? One variable I. Okay, so how am I supposed to fix this problem? Easy, we just use another variable, right? Use J in one other subroutine. Now that works, but yep, go ahead.
Couldn't you also make the variables local to the subroutines?
Yep, that's the proper solution. But we want to explore the easy solutions first and explain why they are not, the best way to fix this problem. So the easy way to fix the problem is just have one of these subroutines use a variable J instead. Okay, if we have 2 variables and one subroutine only uses one of them and the other one uses the other one, then we won't have this problem anymore because they have different counters again. Okay, that works well when you have 2 subroutines. Would it work well when you have 5,000, 50,000 subroutines?
No.
Why won't it work with 5,000 subroutines?
Come up with 5,000.
How do you know which subroutine is using which global variable, right? I got an easy solution for that too. See, I always have easy solutions. We can always prefix the name of a local variable with the name of the subroutine. In other words, I can keep the name I. Instead of I call this print lotto 4 times underscore I. And the other one, I would call that print lotto 2x underscore I. So now each and every I is different because it is prefixed by the name of the subroutine that is supposed to function in. Why would even that be a bad idea?
Type that much more.
Exactly. Well, you have to type more, which also means there are more chances of a typo, right? So if I have a typo, in other words, in print lotto 4 times, somehow by accident, because I just looked at this line here, and I accidentally used print lotto 2x instead of 4x, do you think the compiler or the tool that I'm using will say, hey, this is the wrong name to use inside this subroutine here? No. So that will be a pretty silent error. It's a logic error, and it's going to be very silent because the program is just going to use the wrong variable at the wrong place. Okay? So we don't really have an easy solution unless we use local variables. Okay? Okay, so that's why we don't want to use global variables. So let's go. This is already saved. That's good. So I'm going to save the file one more time, and this time we will use the file name that is indicative of my point. Local variables are good. Okay, so when you look at the file name, you should know what it is about. And the funny thing is, to fix these programs, all I have to do is to insert a row here, insert rows, and then we say I is now a local variable. Local I doesn't really have anything to do, except it is declaring that I is now a local variable. There's nothing to do over there. And I can do the same thing here. Insert rows, and then we say I is now a local variable. So from the syntax perspective, I haven't really made a whole lot of changes. But in terms of the trace, I have changed practically the entire trace, because a local variable it behaves very differently from a global variable. Okay, so let's describe what a local variable is and how it is different from a global variable. First of all, who gets to see it? Okay, who gets to see this variable I here that is local to print lotto 4 times?
Just that subroutine.
Just that subroutine. Okay, so that means on line 17, if I say I gets 10, that I will not be referring to this I, because this I is only visible when you are inside print lotto 4x. Okay, what about the other subroutine, print lotto 2x? It has its own local variable I. So that subroutine also cannot see the local variable I of print lotto 4x. Okay, so that's what we call the scope. Okay, the scope means which part of the program can see which variable. In this case, variable I of print lotto 2x is visible only within this portion of the entire program. Variable I of print lotto 4x is only visible within this portion of the entire program, because each one is local to the subroutine that defines it. Are we doing okay so far with the scope issue? Okay, it's kind of like each subroutine is kind of like a cubicle, and now instead of having one stapler for the entire office complex, each office now has its own stapler, and the stapler stays in the office. There's no way you can borrow a stapler from somebody else. Okay, it is your stapler. Are we doing okay so far? But that's not the only thing about local variables that makes them special, because they are not only local to the subroutine, they are local to that particular invocation of a subroutine. Okay, so let's go ahead and see what I mean by that, because that statement is a little bit difficult to interpret, and the best way to do it is to illustrate what I mean by that. First of all, I don't have that part anymore, because at this point I don't have any global variables anymore. I is local, so that's the first thing you notice is I don't even pre-allocate a column for either of the I variables in the subroutine. They don't exist yet. Okay, so that's the first thing you should remember, is local variables do not start to exist by default. Okay, fine. Now we go to line 17, just like usual, and then we invoke, invoke print lotto 4 times. We still have to do the same thing as before. Okay, allocate the leftmost available column, label it return line number, and remember where we're supposed to go back to, and then continue execution on the first line of the subroutine that we're invoking, which is line 11 in this case. That's the same stuff that we have to do as before. But now, instead of just allocating one column for the return line number, we have to allocate another column for the local variable. Okay? Yep.
When we're naming these columns, do we need to give them any sort of name that's indicative of what subroutine?
Just so that we know what it is for.
So it's all right to do I right there when we're going to have 2 I's?
Yes, we'll end up with 2 columns with the variable I, but the line that you execute your program will imply which subroutine you're in, and therefore you should be able to resolve which I we are referring to. Okay. So we have to reserve another column from the left, and this time we reserve it for the purpose of the local variable I that belongs to print lotto 4 times. Now when you allocate for a local variable, you always have to say it has an unknown value to begin with. Okay? This part depends on the programming language. In certain languages, like in Perl, in PHP, and other scripting languages, when you have a local variable, it starts with a defined value. It's always null or nil, which is basically kind of like 0, but it's not exactly 0. But when you do this in C, it starts with an unknown value. In other words, it has a value, It's just that you don't know exactly what it is. And that's why we always use a question mark to represent the initial value of a local variable. So remember that well, because if you depend on the initial value of a variable in C, then your program will work sometimes and not work other times. Okay? So you always have to assume that it is unknown, and before you use it, you have to initialize it. Are there any questions at this point about why we have to use column D? It's because a local variable is local to an invocation. It does not exist before the subroutine is invoked. It only starts to exist when the subroutine is invoked. Okay. So on line 11, what do? We initialize that to 0. Okay. And then on line 12, we have the beginning of the loop. I is less than 2 is true because I has a value of 0. Then we go to line 13 and we invoke print lotto 2 times or twice. Okay, so we do the usual thing. We have to allocate the leftmost available column for return line number. Remember, we have to remember where to go back to, which is line 14. Then we can remember to continue execution on the first line of the subroutine that we're invoking, which is line 3. But on top of that, we also realize that print lotto twice also has its own local variable I. So now we have to allocate another column from the left and call that I. And once again, since it's a local variable, it always starts with an unknown value. Okay, so this time, at this point, we have 2 columns. Both have the label of I. Column D has a label I. Column F also has a label I. On line 3, we are supposed to initialize I to 0. Which one am I supposed to use?
That's right.
We should use the rightmost definition, okay? Which basically means at this point, since, okay, if I know that I'm executing line 3, which subroutine am I in? We're in the first subroutine, print lotto 2x. So that means this is basically all that I can see from inside that subroutine, because anything that belongs to another subroutine, I cannot see anymore. Okay? So that's why when I refer to I on line 3, I'm only referring to the I as in column F. So now this one gets initialized. Do we have any questions at this point? Okay. After line 3, we go to line 4. Line 4 is asking, I is less than 2. Is true or false, and it is true because I is 0. On line 5, we print the word lotto. On line 6, we increment I. Again, which column am I incrementing? We're incrementing F, column F. So column F is going from 0 to 1. And then we go back to the beginning of the loop on line 4. 1 is less than 2 is still true. Then we go to line 5 again. We print lotto another time. And then we go to line 6. We increment I again. And which column should we use?
F.
Column F. And you can see why we don't have a problem this time, because we actually do have 2 separate counters in this case. We go back to line 4. I is now 2. 2 is less than 2 is false. So we have to go to line 8, which is the end of the subroutine. Okay, the end of the subroutine will still do what it used to do. Okay, you have to look up the rightmost return line number and use that to tell you where to go to continue execution. The rightmost return line number, which is column E, tells me that I have to continue execution on line 14. Okay, we can continue execution on line 14. Now it's time to deallocate stuff. Remember, whatever you allocate at the beginning of this invocation, you have to deallocate. So this time it's not just the return line number that I have to deallocate. I also have to deallocate the column that I allocated for the local variable I. Okay? So now I have to deallocate both of these columns and mark both of them as available after this point. Then I go back to line 14. Line 14 says I want to increment I by 1. The rightmost definition of I is now column D. And and that's what I use to increment. So this now becomes, it goes from 0 to 1. After line 14, I go back to the beginning of the loop on line 12. Line 12 is asking, is I less than 2? The answer is true because I, which is column D, has a value of 1. 1 is less than 2 is true. Then we go to line 13 again and redo the whole thing. And at this point, I can copy and paste this part. Just stick it here. If you want to keep an eye on everything, this is a little trick you can do, is to kind of display the first portion of the screen using the first pane, and then the second pane you can scroll separately. So this way it's easier to keep track of everything that we are doing. After this line 8, we continue execution on line 14 again. Line 14 will add 1 to I. I is 1 at this point, so now it becomes 2. Then we go back to line 12. And line 12 is asking, is I less than 2? The answer is no, it is no longer true, because 2 is less than 2 is false. Then we have to go to line 16, excuse me, to get out of the subroutine. And once again, we have to look up the rightmost return line number, which is column C. It tells us we have to go to post, and then we have to remember to deallocate not one, but both columns that we allocated earlier for this invocation. We get rid of that, and that's the end of the trace. Are there any questions about this? No?
Why did you copy this?
Why do I copy the...
The same thing?
Sorry? Why do I copy
The first part twice.
the first part twice? Because I'm invoking it again. I just don't feel like, doing exactly the same thing again. Because every time you invoke print lotto 2x, it will do exactly the same thing. Okay. Are there any questions about local variables at this point? No questions? This is all good? Okay. Let's go ahead and save this one and work on another example. The next one is going to be recursive. In other words, let's try to write our factorial logic in a recursive way. So this time we'll say define sub factorial, and we have a local variable here that I'll call n. The first thing I do in the subroutine is I'll make a copy of x, which is a global variable in n. Then we'll use n from now on. We'll say if n is greater than 0, then we want to decrement x by 1. X gets x minus 1. Invoke factorial again. When factorial comes back, I have to compute the result. The result is going to be kept in x. X will get x times n. And then we have an else. The else is, what if n is less than or equal to 0? Then the result is going to be a 1. And if n defines sub, and then we'll go ahead and fix all the indentation stuff. And then outside of the subroutine, I will set up x, which is the number, whose factorial I'm trying to figure out. So we'll try to figure out what is 2 factorial in this case, and then we'll go ahead and invoke factorial. That's the sample program, and let's see what it does. Are there any questions about the algorithm itself? Okay, it has some resemblance to the other algorithm that we looked at earlier, except this one makes use of the local variable n, and it has some calculations unlike the previous one. So the question is it going to compute 2 factorial in this case? Is it going to work? We'll find out by tracing it. So we'll trace this as factorial with local variables. So here is the trace. Now every time we trace something like this, it's basically another exercise to use the same concepts. So look at it as an exercise. There was also some questions as to how do we study for this class. one thing you can do is, all these examples that we do in the class, what you can do is you can download a file or you can watch the video and just, basically copy the code and then work on the trace on your own. Okay, you can stop the video clip and just work on the trace, and then when you're done, you can kind of fast forward the video clip to the solution part, and then compare your solution to mine. If I remember to upload the files, you can actually use sheet 3 maybe for your own trace. Then you can compare sheet 2 to sheet 3 just to compare your trace versus the trace that we did in the class. It won't work if you guys have photographic memory. If you have photographic memory, you can just regurgitate, oh, I remember exactly how the whole thing looks like, then you don't have to exercise the actual mechanisms to come up with the answer. But most people do not have photographic memory that is detailed enough to remember all the little things. So most of the time you can just revisit sample programs that we traced in the class as an exercise. Okay, it's not going to be graded, but I think it will still be a good exercise because you have the solution next to you, and you can also watch the YouTube clip to see why the result is the result. So that's why it's also good from that perspective, because the explanation is already there. It's just that you can skip the explanation, work on it on your own, then you can compare your solution to mine. Okay, so here we have sheet 2 as the trace. We have the comments column. We have the line number, and this time we have one single global variable x. As before, the precondition is we don't know anything about x because we don't have to know anything about x. It will be initialized before it gets used. On line 12 is the first line outside of the definition of a subroutine, and that's why we start with line 12. It initializes x to 2. Then on line 13, we invoke the subroutine called factorial. As before, we have the return line number. We go back to post when the subroutine is all done, and then we have to set up another column for the local variable. It only has one local variable called n. N has a startup value or initial value of unknown. Okay, you have to remember this is really, really important when you program in C, because all local variables in C are like this. They have a value, you just don't know what it is. Then we continue execution inside the subroutine that we're invoking, which is factorial. Line 2 doesn't really do anything, so we don't track line 2, we track from line 3. Line 3 is asking, is n greater than 0? The answer is true. Oops, I got it wrong. Okay, line 3 is copying the value of x to n. X has a value of 2 at this point, so now n also has a value of 2. Then we go to line 4, which asks the question, n is greater than 0 is true, because n has a value of 2 at this point. Then we go to line 5. Line 5 is decrementing x. X goes from 2 to 1. Then we go to line 6. Line 6 is invoking factorial again, so we have to allocate 2 more columns. One for the return line number, one for n. The return line number in this case is the line that is logically following line 6, which is line 7. N is a local variable, so it always starts with a question mark. Are there any questions at this point? No? Okay. Then we continue execution in the subroutine that we're invoking, which is factorial. And we start with line 3 again. Now this is also very important. You have to start from the beginning every single time when you invoke a subroutine. On line 3, we are copying the value of x, which is column C, and now it has a value of 1 to n. This time n refers to column G because this is the most recent invocation. Okay? Now right here, I should stop a little bit and talk about why I said something that I said earlier, and I said, okay, you may not be able to understand it because we don't have the necessary setup. You can see that we have only one subroutine, right? We have only one subroutine called factorial, or FACT, fact. And yet we have 2 variable n's, okay? Because you can see that column E is a variable n, and column G is also a variable n. Now this is a very important concept because it's telling you that a local variable is not on a per subroutine basis. is on a per invocation basis. If you have 200 subroutines and none is invoked, guess what? No local variable is created. If you have one single subroutine and it is recursive and you end up with 20,000 invocations of the same subroutine, guess what? You have 20,000 copies of the same local variable. Okay? In this case, at this point, we have 2 invocations that are active, so now we have 2 local variable n. Are we doing okay so far with the concept? Local variables are allocated on a per invocation basis, not on a per subroutine basis. Subroutine is static. You can look at it as the source code. Invocations are dynamic. It is a runtime concept. You don't know how many invocations there will be until you run the algorithm. Are we doing okay so far? You know, the differences between what is an invocation as opposed to what is a subroutine. Yes? Okay. So now we can continue the execution on line 3. We are done with line 3. We move on to line 4. N has a value of 1 because this n refers to column G. 1 is greater than 0 is true. Then we go to line 5. Line 5 decrements x one more time, so x now becomes 0. We go to line 6. We invoke factorial 1 last time. We still have to allocate 1 column for return line number, another one for n. The return line number is still line 7 because line 6, line 7 follows line 6 logically. And this n is always starting with unknown because it is a local variable. So basically we are doing exactly the same thing, and we end up with 3 invocations of the subroutine factorial. After we set up the 2 columns, in this case column H and column I, we continue execution from the beginning of the subroutine that we're invoking. We're invoking factorial. The first line is line 3. So now we're back to line 3. Line 3 makes a copy of x into n. So n is now what? 0, because x has a value of 0 at this point. We go to line 4. We ask the question, n is greater than 0. It is false. Okay. Now if that is false, I have to go to the else branch, which means I have to go to line 9 next. Line 9 doesn't do anything that's useful. All it does is to initialize the value of x to 1 for here. Then we get out of the conditional statement. We go to the end of the subroutine on line 11. What do we do at the end of a subroutine? There are 2 things to do. Look up the rightmost return line number, which is this one here. It tells me that I have to continue on line 7. And then the second thing to do is to deallocate everything that we allocated for this invocation. In this case, it is column H and column I. Now mark both of these as deallocated. Are we doing okay so far? We're back to line 7 now. What does line 7 do? Line 7 says we want to compute the product of x and n and then put the result back into x. Well, let's see. What is the value of x at this point?
1.
It's 1. What is the value of n at this point? It is 1. The other n is deallocated, so we cannot refer to it anymore. So the rightmost n has a value of 1. 1 times 1 is 1, and we use that to update x. X is 1 more time. And it's a good time to split the screen so that we can see multiple columns at the same time. So after this, so line 7 has the effect of putting a 1 back into x. And then we get out of the conditional statement. We end up on line 11. Line 11 is the end of a subroutine, and as a result, we have to look up the rightmost return line number, which in this case is column F, which tells me I have to continue on to line 7. And after that, I have no use of column F or G anymore. I deallocate both of those columns, and then I continue execution on line 7. What do we do again on line 7? We compute the product of x and n. X has a value of 1, and this time is column E. It has a value of 2. 1 times 2 is 2. We store the 2 back into x. Then we move on to line 11. Line 11 is an end of a subroutine, so we have to look up the rightmost return line number, which tells us we have to go to post. And then we go back and deallocate these two columns. And then we continue execution at post, which means we're done. So are we doing okay so far with the concept of local variables? Every time you allocate for return line number, you also have to allocate for local variables. Every time you deallocate a return line number, you also have to deallocate the local variable or local variables of that subroutine. Are we doing okay so far with this? Okay. That's pretty much the concept of a local variable. It is very useful because it allows you to use certain variables as your scratch pad. Okay, only you as the subroutine gets to see it, and not only that, every invocation of that subroutine has its own little scratch pad. So there's no confusion of who gets to use which scratch pad because every invocation has its own. Okay, that is great, but we still have problems because we still need the global variable x in this program. What purposes do you think variable x serves in this case? There are two purposes that it serves. Yep.
Serves as a counter.
It serves as a counter. It also serves as the result. Okay? So variable x in this subroutine has two purposes. One, it tells the subroutine factorial, okay, which number's factorial do we want to find as an input. At the same time, it is also where we store the output, the result of the calculation. So that's why I said the global variable x in this particular program serves two purposes. At first, it serves as an input to tell us, which number's factorial we want to find. And then later on, after we get to line 9 and backtrack, then it serves the other purpose, which is what is the result of that factorial. Okay? And at this point, we don't have any other mechanisms to get rid of global variables. But because global variables are evil, we want to get rid of them. Right? So step by step, we'll remove the references to global variables in this algorithm and also in other algorithms. Okay. Are we doing okay so far with subroutines and local variables? Okay. Let's close this and start a new spreadsheet. So in this new spreadsheet, we introduce a new concept, which is not really that innovative. It is called a Byval parameter or by-value parameter. Okay, and we'll illustrate the concept using a fairly simple algorithm, and we'll say this is increment x by k. Okay, and this time we'll do it smart. We'll use a Byval parameter, and we'll call it k. And then we'll say x is incremented by that amount. X gets x plus k, and define sub. And then outside of the subroutine, we say x is initialized to, say, 4. And then we invoke the subroutine increment x k. And this time, the syntax of the invocation is a little bit different because we have to specify the value of k as a parameter from the invoke statement itself. So we'll say, okay, in this case, we just use an example and use 3 to specify the parameter k. I will trace this and explain the concepts at the same time. We have line number, and we do have one global variable here, which is x. But the main point of this particular sample program is to illustrate what is a Byval parameter and what purpose can it possibly serve in this program. The precondition is we don't need to know anything about x because on line 5, which is the first line outside of the definition of a subroutine, we initialize x to 4. On line 6, we invoke the subroutine. We still have to do the return line number thing, so that part is consistent across all subroutines. We have to allocate the leftmost available column, call it return line number, and then remember that we are supposed to go back to post once the subroutine is done. Okay, so that part is the same. But this time, instead of allocating a column for a local variable, we have to allocate a column for a Byval parameter. Okay, in the notes you will see that I refer to Byval parameters several times, and say that it is almost exactly the same as a local variable, with only one difference. Its initial value is specified by the invoke statement. That's the only difference, but it's a very, very important difference. So let me say that again, just in case someone missed that. A Byval parameter is almost the same as a local variable, with one exception. With a local variable, its initial value is always starting with a question mark. We don't know what it is. With a Byval parameter, the initial value is specified by the invoke statement. Okay, now that is a big difference because we have to allocate a column just like with a local variable for k, which is a Byval parameter. However, the initial value of k is no longer a question mark. It is now specified by the invoke statement, which is on line 6. So what should I put here?
I have a different question also.
Sorry? Yeah, go ahead.
Well, on line 6 it says k gets the value of 3. I guess my question is in languages C or whatever, does it matter in which order? Because you're saying it's left to right.
In this class, that's the order that I use,
Okay.
because I don't want to confuse people with an assignment statement, because it is not an assignment statement. This is passing a value of 3 to the parameter k. Okay. In an actual programming language, you don't even spell out which parameter is getting that value. But in this class, I just make it very clear so that in the case of flipping the order of the parameters, there won't be any problems in this class. But in a real programming language, you just say 3, and it is implied by the order of the parameters of which parameter is getting which value. But in this class, I spell it out so that we can see very clearly which value goes into which parameter. Okay, so the order is important. You have to use a right arrow instead of a left arrow in this case. Okay, so k will start with what value again? 3. All right. Not a question mark. It is a known value 3. Now, what is most important is this is outside of the subroutine. Okay, the invoke statement is outside of the subroutine, and yet from the inside the subroutine, we can now see that k equals to 3 initially. In other words, a Byval parameter serves one important purpose. It is the in tray of a subroutine. This is how we can pass information or numbers or values to process into the subroutine, so the subroutine knows, oh, I'm supposed to add this number to x, or oh, I'm supposed to find the factorial of this number, without the use of a global variable. Okay, so this is we're one step closer to eliminating the need of global variables in a subroutine. Okay, so now we go into the subroutine. The first line inside the subroutine that has something to do is line 3. Line 3 is just saying x gets x plus k. X has a value of 4 at this time. K has a value of 3 at this time. 4 plus 3 is 7, and we use 7 to update x. So x is now becoming 7. We go to line 4. Line 4 is the end of a subroutine. We have to do the usual thing. We look up the rightmost return line number, which is column C. We look it up and say, okay, we are supposed to continue at post. And then once we find that out, we have no use of column C or D anymore. And then we deallocate both columns. So from the allocation and deallocation perspectives, a Byval parameter is the same as a local variable. Okay? It does not exist until a subroutine is invoked. It goes away as soon as we get out of the subroutine. It is also on a per invocation basis. So the only difference, as I said many times already, is that it starts with a value, and that value is specified by the invoke statement. Are we doing okay so far with this? Yes? We're just adding something on top of the other ones. We are just adding a little bit more each time, and now we have Byval parameters, which is a in-tray concept. Okay. If there are no questions about this, I'm going to save it first, and then we'll go back to the factorial example again. Now the reason why I go back to the factorial program again is because I want to show you what we can do to improve the algorithm as we understand more types of concepts. So this time we'll get rid of one use of x. We still need x for one last purpose, but we don't need x to serve the purpose of input anymore. So we'll go ahead and take a look at what we can do to do that. So this time, instead of a local variable n, I say Byval n. Now this, even though syntactically it's a very simple change from local to Byval, in terms of the meaning of the program, it is tremendous. Because now we can do something like this. Now we can say right away, if n is greater than 0, then now we also have to go compute the factorial of n minus 1. But this time, the communication between the code to invoke and the subroutine that we're invoking is much easier. Because this time I can say invoke factorial, use n minus 1 to specify parameter n. Okay, now this looks awfully confusing, so by the time we trace it, we'll find out what it does. When factorial comes back to line 5, we'll go ahead and continue to compute the result. So we still need variable x to serve that particular purpose. We still need it to pass the return value or the result back to the caller or the code that invokes this subroutine. So that part we cannot bypass just yet. So we still need x to be in this subroutine. But we have eliminated one of the purposes of x in this code. So gradually, step by step, we'll remove all global variables in this subroutine. Okay. And this time, I can say invoke factorial to specifies the value of n. I don't need to initialize x anymore because the Byval parameter n is now serving the purpose as the input into the factorial subroutine. Are we doing okay so far with the concept? Kind of? Okay, if you guys have any questions, this is a good time to ask before we actually go in and trace the algorithm. I'll just stop here for a moment and wait for questions. Any questions? No? Okay, let's trace it first. During the trace, if you have any questions at any time, just stop me and then ask those questions, because we are adding concepts upon concepts upon concepts, and if you have any questions at any step, you should ask the question, because otherwise it's really hard to stack up the concepts. So we'll go ahead and got to open a new window first. Okay, so no. Here we have sheet 2. Make sure we save the file first. And this time when I save the file, it's going to be factorial with Byval parameters. We need one column for comments because we do have conditions to evaluate. We have line number, and we still have one global variable x, because it still has to serve the second purpose, which is to serve as the mechanism to return the value of the computation. Precondition is we don't know anything about it. We'll get it initialized later on. The only line in this program is line 10, outside of the definition of a subroutine. So we'll use the same thing. We allocate 2 columns, one for return line number and one for the Byval parameter n. Yep.
Where is x initialized? Is it in line 5 or?
Yes. Well, it will be it will encounter line 7 first.
Oh, okay.
So so that's a good
Okay,
question.
Yeah.
Yeah, but it's a good question. The question is, don't we need to initialize x, so it has some meaning? And according to this logic here, we are guaranteed to encounter line 7 first before we encounter line 5. So by the time we get to line 5, x will have a defined value already. Okay, so when we trace it, we'll see the pattern. The return line number should be what? Post, because line 10 is the last line of the program already. What about this n here? What should it be?
2.
Should be 2, because it is spelled out here that we want to use 2 to specify the Byval parameter n. Then we continue execution inside the subroutine, starting with the first line in the subroutine, which is line 3. This is almost the same as before. N is greater than 0 is true. We go into the then case, which is on line 4. This part is a little bit confusing now. Okay, it is confusing because we refer to n on the left-hand side and also on the right-hand side of the right arrow. So the question is, what am I supposed to do? I know that we have to allocate 2 additional columns, one for return line number and one for n. The return line number is the easy one to take care of because the invocation happens on line 4 and line 5 is the line that is logically following line 4, and therefore the return line number is line 5. That's the easy one. The question is, what am I supposed to put here? What do you think? If you look at line 4, it looks kind of confusing because it refers to n. So which n am I referring to on the left-hand side? Which n am I referring to on the right-hand side? Okay, so think about it this way. Look at the left-hand side of the right arrow. This n minus 1. Don't you think that I need to know the current value of n in order to compute n minus 1? So which n has a known value already? Which column? Column E. Okay, column E has a known value of 2. So that means the left-hand side of the right arrow refers to values that we know already at this point. So that's basically column E, which has a value of 2. 2 minus 1 is 1. So the second question is, what am I going to change to 1? Am I going to change column E to 1, or am I going to change column G to 1? I'm trying to set up column G, right? So I'm actually specifying that column G should start with a value of 1. Is that okay? I mean, this is the part that can be a little bit confusing because we are referring to n both on the left-hand side and also on the right-hand side. The left-hand side refers to stuff that we know already, okay, not the stuff that we are trying to define. The left-hand side of the right arrow refers to the column that we are trying to set up. And that's why we have a right arrow. The arrow indicates which way is information going. Are we doing okay so far with the example here? Okay. After we set up column F and column G, we continue execution from the beginning of the subroutine that we are invoking, which is line 3. N is greater than 0 is true because n has a value of 1 at this point. We go to line 4, we invoke factorial another time. Return line number and n. I'm shrinking the column first so we can fit everything on the screen. So about that. Okay. The return line number, once again, is the easy one. We have to go back to line 5 because the invocation is on line 4. What about this n here? We are once again using n minus 1 to specify n. It will be 0 this time because the n on the left-hand side refers to column G, which is the current context that I'm in. The n on the right-hand side refers to the n of the next context of the next invocation, which is column I in this case. N at this point is column G. It is 1. 1 minus 1 is 0. That's why parameter n of the next invocation starts with a value of 0. Okay? Then we continue execution again in the subroutine that we are invoking starting from the beginning, which is line 3. N is greater than 0 is false. Okay? So we have to go to the else case now. The else is line 7, and the only thing we have to do on line 7 is to initialize x to 1. So did that answer your question? About how come we don't have to initialize x to begin with? Because according to this logic here, we are bound to encounter line 7 first. Then when we go backwards, then we'll encounter line 5. Okay. So after line 7, we are at the end of the subroutine. We go to line 9. Line 9 is the end of the subroutine. We have to do two things again. The first thing is to look up the rightmost return line number, which is column H. Column H says we have to go to line 5 to continue execution. But after that, after we look up the return line number, we have to remember that these two columns are no longer useful to me, and they are now deallocated. That leaves me on line 5 at this point. Line 5 is trying to compute x times n, and then use that to update x. N is column G at this point. It has a value of 1. X is column C. It also has a value of 1. 1 times 1 is 1. I update x with that value. After line 5, I get out of the conditional statement. I end up on line 9. And on line 9, I do exactly the same thing. I look up the rightmost return line number, which is column F this time. It tells me I have to go back to line 5. Here we go. And we also have to remember to deallocate those two columns. And now we continue execution on line 5. Do you have any questions? Hello? Are you guys doing okay? Okay. We're back to line 5. Line 5 is going to do about the same thing. We have to compute the product of x and n. N is column E because the other n's are deallocated already. Column E has a value of 2, and x, which is column C, has a value of 1. 2 times 1 is 2. We store the 2 back into x, so the x is now updated to a value of 2. After line 5, we are done with the conditional statement. We go all the way to the end of the subroutine on line 9. Line 9 being the end of a subroutine, we look up the rightmost return line number, which is column D. It tells me to continue execution at post, and then we have no use of columns D or column E anymore. We deallocate those two columns, and then we continue with post, and that means we are done. Okay? Is that okay? I mean, because if you have any questions, it's a good time to ask those questions before we start on the next type of parameters. Is that good? Okay. So we are, as I said, we are gradually removing the reference to global variables in our subroutine because the idea or the purpose is to eliminate the need of global variables altogether. What is the purpose of x in this particular subroutine? What purpose does it serve right now? Why do we still need the global variable x? For the output, okay? Because the factorial subroutine is supposed to compute the factorial of n. Well, n is good because it makes it easy to tell the subroutine which number's factorial do we want to compute. But once we compute the factorial of that number, how are we going to let the outside world know about the result? The only mechanism that we use at this point, that we can use at this point, is the global variable. So now we'll start to use another concept to get rid of the global variable altogether. But before we can talk about the Bivalve parameter, let's go ahead and look at another sample program. And this time it is about how do we exchange the values of two variables. Okay, the logic to do that. Okay, so we'll start with this new program, and we'll define a subroutine called exchange because we're exchanging the values of two variables. Does everybody understand what I mean by exchanging the values of two variables? if variable x had a value of 3 and variable y has a value of 5, 3 and 5, after the exchange, then the values will be swapped. Variable x will end up with 5, and variable y will end up with 3. That's the logic of exchanging the values of two variables. So we'll go ahead and try to do a Byval here because it is such a cool concept. We will try to use it as much as we can. So here are the two things that we want to exchange the values for. And in order to exchange values, we need a third variable as a temporary variable, which we'll just call it t. The logic is actually fairly easy. You take a snapshot of the value of x first before you destroy it by copying the value of y into it. Then you can overwrite the value of y with the old value of x, which I stored into t, and that's the whole thing. And that's the logic of exchanging the values of two variables. And now we have two global variables. I will call the first global variable I. Okay, I starts with a value of 3. J is the second global variable. It starts with a value of 5. And I will say, oh, okay, the subroutine exchange seems to be doing a good job of exchanging the values of its parameters. So what I'll do is I'll just invoke the subroutine exchange. I use I to specify parameter x. I use j to specify the parameter y. And hopefully this will help me exchange the values of I and j. Okay? Now, obviously this is not going to work. But the question is, where is it not going to work and why is it not working? So we'll take a look at this and find out what this program is doing and why it is not accomplishing what it should be doing, what it should be accomplishing. And before we do that, we save the file. We'll say exchange with Byval parameters. Okay. We have line number, we have variable I, we have variable j, and we have line precondition is we don't know anything about I or j, we don't need to. And then on line 9, we initialize I to 3. On line 10, j gets an initial value of 5. On line 11, we invoke the subroutine exchange. This time we have to set a return line number as well as the parameters x and y, as well as the local variable t. Are there any questions about why we have all these columns this time? Okay, because all the local variables and all the parameters need columns allocated on the fly per invocation. So that's why we have columns D all the way up to G allocated in this case. The return line number is easy. It is just post because line 11 is the last line of the algorithm. Parameter x, what should I put here? Should I write I here or should I write 3 here? Okay. There is a reason why a Byval parameter is called a Bivalve Parameter. So should I use I or should I use the value of I? The value of I. So that's why we have to use 3 here. And what goes into y? That would be 5. And what goes into t?
3.
Nothing right now, but we have to put something in that cell. Question mark. Okay? You have to remember it's a question mark so that we know for sure it is unknown. Okay? Alright, so now that we have set up all 4 columns, we can continue execution inside the subroutine starting with the first line, which is line 5. Line 5 says make a copy of x into t. Okay? X has a value of 3, t is going to end up with that value. On line 6, we want to copy the value of y into x. Y has a value of 5, so x now ends up with a value of 5. And on line 7, we want to copy the value of t, which is a backup of the old value of x, into y, and that's 3. So when you stop right here, the exchange logic works flawlessly, okay? Because x was 3, and y was 5, and now x is 5, and y is now 3. The exchange worked. But what do we do on line 8? On line 8, we first have to look up the return line number, which is post. Okay, so we remember first we have to go to post. Then we have to, guess what? Throw everything into the shredder.
Yeah, it's another thing.
And now we get back to the beginning, and nothing happened to I or J. In other words, the logic is good, but the type of parameter did not work. Okay? We were so close. We were so close to getting this done. It's just that we can't get the result back out of the subroutine. Okay? So that illustrates, this program illustrates the limitations of Byval parameters. It's great as an in-tray, but it doesn't do anything when you want to pass information or results back out of a subroutine. Okay? That's the limitation of a Byval parameter. Now let's go ahead and fix this program. I mean, this is obviously not working. We'll go ahead and fix this program. I will save the new program as a different name. This time, instead of Byval, we have byref or byreference. Okay? The syntactical change to the program is trivial. Every time we see Byval, we change it to byreference. Every time we see by value, we change it by reference. And we also change the arrows. Okay? When we change the type of the parameter, we also change the arrows because the arrow is indicative of which way things are going. This time we change it to a bidirectional arrow, which is meaningful. Okay? I don't choose the type of arrow just because it looks good. It's because it actually tells me what it is doing. Okay? So just looking at this invocation line here, okay, it's telling me I'm trying to use the arrows to tell us what's going on between I and J. This tells me that whatever is in I is also in X. Whatever happens to X will also happen to I. They are basically the same thing. Okay. The question is, how do we represent it? What is the mechanism that makes this work? The first 3 lines are the same. Okay. We have line 9 initializing I to 3. We have line 10 initializing J to 5. Those 2 lines are exactly the same. On line 11, I can even keep row 5 because I have to allocate for by reference parameters just like I have to reserve space for by value parameters. But from here on, they are different. Okay, so I'm going to change the program or change the trace after this point. I need more space in column E. I need more space in column F. Because now I need a way to say something to the effect of, oh, guess what? X is just another way to refer to column B, and Y is just another way to refer to column C. That's what we want to say. Okay? When you pass something by reference, you are telling the subroutine where to find something or how to find something. Okay? So let's use an analogy before we go forward with this trace here to illustrate the differences between Byval and byref. Okay? Let's say we are checking out books from the library. Okay, so here inside, this is a room and this is a subroutine. Okay, it's a subroutine, and let's just say that somebody messed up the books in the library. They wrote something on the books, and my job is to erase all the markings, additional markings on the book, fix it up, tape it up, and then put it back on the shelf. Okay, that's my job, is to fix up the books. Byval means, if I say, okay, give me a book Byval so I can clean it up, that means make a photocopy of the original book and give me the photocopy. That's what it means when you use Byval parameters. The subroutine is working with a copy of whatever you're passing to it. So I will take the copy of the book that I'm supposed to clean up. I'll do everything that I can to clean it up. And what happens to the copy at the end of this subroutine?
It's destroyed.
I throw it into the shredder. Okay? Because everything that you give me, you being, the code outside of the subroutine, everything that you give me that is created or allocated on the fly using the additional columns, I have to throw it into the shredder. Okay? So obviously that's not working. It's not working the way it's supposed to. So I clean up the book, but that book is actually a copy of the original book. Okay, so the obvious solution is to give me the original book, right? Well, that works in real world. It doesn't work inside the program. Because inside the program, there's no way to move something from one place to another place. Okay, because let's think about this. Okay, in real life, I have an object. Okay, I can hold an object like this, and I can say, now the object is here. And if I need it somewhere else, I can physically move the object to somewhere else. I can put it here. It is no longer over there. But it doesn't work when you're working with computers, especially the memory system of a computer. You cannot move content from one place to another place. And as a result, it is not possible for you to give me the original book, even though that's what we need to do. But one thing you can do is to do it like this. Instead of giving me the original book, you still give me you still give me a copy of something. But the copy that you give me is a copy of the call number of that book. Does everybody understand what is a call number in the case of using a library? Yes? Okay, everybody? Okay. So basically a call number is a way for me to find a book in the library. So instead of giving me the book, the original book, you give me a little slip of paper like this, and on that paper you write down the call number of the book that you want me to clean up. So you will write down, QA, I think it's 8078, for most computer books, and then whatever that's after that. That's what you give me. This is a Byvalve parameter. It is not a book. It is not a copy of the book. It is not the original book. It is instruction to tell me how to find the original book. So as a subroutine, now I can go to the library and I can find where the original book is, and I will work on the original book as I clean it up. Okay? Is that concept okay so far? You're not giving me the book, you're giving me the information that I need to find the book, to find the original item. Okay. When I'm done as a subroutine, I'm obligated to remove and shred everything that you gave me. So what am I going to shred? This little piece of paper. So I put it into the shredder. Okay. What happened to the book that I just cleaned up?
It's still on the shelf.
It's still on the shelf, still cleaned up. Okay? So that's how passive by reference works. Okay? You are not giving me the original book. You're not giving me a copy of the book. You're only giving me a little slip of paper so I know how to find the original book. I still have to destroy that little slip of paper. But guess what? It doesn't do any harm to the book that I just processed, because it is just instruction for me to go find a book. I can destroy that instruction because it is no longer useful to me at the end of the subroutine. Is that working okay in terms of concepts? Okay. So that means, in a trace like this, parameter x is nothing more than the call number of quote-unquote the book that we refer to as I, or column B. Okay? But instead of using a call number, I would use the concept of an alias. So basically, I would say parameter x is also known as column B. We'll say parameter y is also known as column C. Now, this is where I make the most differences between the old version of these notes and the new version of these notes. In the old version, I would say x is also known as I, y is also known as j. That's the old way of doing things, but it's imprecise. Because what if I have multiple I and multiple j's? Then it's really hard to say whose I I'm talking about and whose j I'm talking about. When I refer to column numbers, it is absolute. Okay? There's only one column B, there's only one column C, and this is the new way of doing things, and that's why I referred to the notes earlier and told you guys, okay, read this one because it is more up to date, because I have changed the way things are presented. Okay? Okay, so this is all good. We know how to represent x, we know how to represent y in a trace. Now the question is, what are we going to do with these lines 5, 6, and 7? Line 5 is the easy one, because line 5 says we want to find out what is the value of x, and then we use it to update t. What is the value of x? Let's look it up. X is also known as column B. So that means x itself does not really have a value. It is nothing more than an alias. It has no value. So in order to answer the question of what is the value of x, I have to look at the column that it refers to, which in this case is column B. Column B has a value of 3, then I use 3 to update local variable t. Are we doing okay so far? Looking up a by reference parameter. What is more mysterious is number 6, or line 6. Because with line 6, the right-hand side is easy. We just reapply what we have learned a little bit earlier. Y is column F. Column F is an alias of column C. We look up column C, and then we see that column C has a value of 5. The right-hand side is 5. That's fine. We know how to deal with that. The question is, what are we actually going to update when we update x? Are we updating column E, or are we updating what it is referring to? That's the question. Okay, now try to relate what we are seeing here with the analogy that I told you a little bit earlier. When I clean up the book, am I cleaning up the call number, the little slip of paper that you have written the call number, or am I cleaning up the book that the call number is referring to? I'm cleaning up the book that the call number is referring to. So in this case, it's the same thing. When you update x, you're not updating that little slip of paper to tell you what x is or what it is an alias of. You are updating what x is referring to. In this case, it's referring to column B. A column B, column B is the one that is updated using the value 5. So in this case, column B now becomes 5. Do we have any questions now? Because this is the essence of passing by reference. And this is why it is so different from passing by value. Okay? Yep.
Can you explain one more time how do you get this 5 to the x?
Okay, according to line 6, I'm supposed to use 5, which is the right-hand side, to update the left-hand side, which is x. Is that okay so far? Okay, if I'm not updating column B, what do you think I should be updating? It's an assignment statement. I have to update something, right? So the question is, which column am I supposed to update? There are only two choices that are logical. One is update column E, because that's x. The other logical choice is column B, because that's what x is referring to. Right? Those are my only two choices that make sense. So, but you have to remember the call number example. This is x. X is nothing more than a little slip of paper with the call number of the book written on it. Okay? So when I'm supposed to clean up the book, am I cleaning up this little slip of paper, or am I cleaning up the book that this little slip of paper is referring to? I'm cleaning up the book. So it's the same thing here. X is the call number. The book is I, which is column B. So when I change x, I'm actually changing what it is referring to, and therefore the name is passing by reference, because you're not changing the parameter, you're changing what it is referring to. The parameter is a reference to something else. You had a question?
Why not T?
Why not T? You mean here?
Yeah.
Because T is a local variable. A local variable is not a reference to anything else. It is a little bit of a scratch pad that you can work with. So this mechanism
Temporary note to self.
is a variable.
It's not an assignment.
Yeah, any local variable is not a reference to something else. So when you update a local variable, you update the column. I mean, if you look up column G, what else can I possibly update? It is not referring to anything else. Okay? But when you look up x or y, they are aliases of something else, and that's why you update whatever is an alias of. Is that okay? I mean, this is different. It is stacking up on top of the topics that we have worked on today, and it's a lot. We covered a lot of grounds today. Yep.
So when in line 7, when y gets t,
Yep.
essentially j would get
Yes.
hit as well.
Yep. So let's work with line 7. On line 7, okay, line 7, we are we evaluate the right hand side first, which is easy because the right hand side refers to t, and t has its own value of 3. So the right hand side evaluates to just a value of 3. The left hand side refers to y. Y is column F, but y itself does not have a value. It's not a bulk. It's just a call number. So when we update y, we have to update what y refers to, which in this case is column C. And column C is the one that will get updated by the value of 3. Okay? Are there any questions about this part here? No? Okay, go ahead.
Do you have to have the variable t in there, or is that, I mean, can it just go from it
No,
knowing that it's going to
well,
be
okay.
from C?
You are referring to the logic of the exchange
Yeah.
operation. There's no way you can get away without a temporary variable, because the moment you destroy one of the two things, you cannot get back to its old value. Okay, so you need a third variable as a snapshot or a backup before you destroy one of the two. Then you can update that guy, and then the other one can get the backed up value of the first variable. So this is the only way, this is the shortest way to do exchange, given that we only have assignment statements. Now, we're done with line 7. We go to line 8. Line 8 is the end of a subroutine, and the obligation of a subroutine is whatever is allocated to you earlier, you now have to deallocate. So this time, we still have to deallocate columns D, E, F, and G. They're all gone. Okay, after we look up the return line number and remember to go to post. Well, did anything happen to I or J?
Yes.
Okay, we did exchange the values, but when I remove the columns D, E, F, and G, did that change anything about I or J? What about the effect of the exchange? Did we undo anything about the exchange operation? No. Because what did we throw away? What did we throw into the shredder?
Call number.
The call numbers. What happened to the books that the call numbers refer to?
Stay on the shelf.
They're fine. Okay? They're exactly where they were before, but this time they are now processed. Okay? They're whatever operation I performed to the books sticks because they were done to the original items. So are there any questions about the concept of passing by reference at this point? No questions? We have 5 minutes left, so what I'll do is I'll give you your homework assignment because I keep forgetting to do that, which is bad. Okay? I always said, I go back to the office and I'll work on it, and then when I get back to the office, I have a meeting starting at 12 o'clock, and one of the attendants of the meeting is the professor who is next to me, and then we just start to talk about the meeting, and then I just completely forget. So this is what I'll do. This is not bad because you can actually see how I create the homework assignments in Moodle. And so we'll go ahead and close this first, and then start a new spreadsheet with the new code. So what we'll do is we'll talk about factorial again, because by this time we are all experts of factorial calculations, right? Except this time we'll use most of the concepts that we have talked about today. Not all, let's use all. Okay, we'll use all the concepts that we have talked about today. Trust me, it's not that bad. It's not that bad. Okay, so we'll use Byval to pass in n, and then we'll use byref to pass the result back, okay, which is r. We say if n is greater than 0, then invoke factorial again, and we'll pass n minus 1 to n, and we'll pass r to r. Okay? Now you need to read the notes a little bit to figure out how to pass something that was passed by reference to you along to something else, also by reference. It is already in the book, okay, in the notes. Okay, so that part is in the notes, but you do have to kind of look it up and finish that part. And then after this, we can say r gets r times n, and then the else is just r gets 1, and if and define sub. Okay. That's one subroutine. And then we will define another subroutine that I just call stub, okay? Because it is just basically a stub. I have a local variable called I. It doesn't matter what the name is. And then we invoke factorial. And this time I specify I want to find a factorial of 2. So 2 goes to parameter n. I want the result to be stored in my local variable I. So I use I to specify parameter r. And after this, I will just print the value of I, so just so that I can print the result of the calculation out, and define sub. So in the only code that is outside of any subroutine definition, the only thing I have to do is to invoke stub. That's all I need to do. So the first thing you want to do is to think about, okay, do we have any global variables in this case? Have I successfully removed all necessity to use global variables? I did. Okay? And it does use most of the concepts that we talked about. The only thing that I have not talked about is this part here. How do I pass a parameter that is passed to me by reference, also by reference to another subroutine that I'm supposed to invoke? And I will point out where in the notes you're supposed to look up so that you know exactly where you have to read. Okay. So what you need to do is to read this part here. We have covered, section 4, section 5, and most of section 6 already. The only thing that we have not talked about is Byvalve Parameter passed by reference again. Okay, that's the only part that we have not talked about that is related to your homework assignment. And if you click that, it has a full example, kind of like this. It's not exactly the same as your homework assignment, but it illustrates all the concepts with all explanations already in the trace itself. So I think you guys can handle this, okay? I think you can just read this portion and get the homework assignment done. And let's see here. If you don't want to see how the homework assignment is created and uploaded, that's basically all you have to do. And I'll save this to, I'll even save it to today's folder so you have 2 places to find it. So I'll call this factorial Byval and also by reference. If you need to go ahead. I'll just be here and finish up this so that I don't forget to give you the homework assignment.
Would you also remember to upload last week's spreadsheets?
Okay.
I was trying to find them this morning.
Last week?
Yeah.
Okay. I will.
As well as this week.
Okay. Good idea.
Thank you.
Okay.
Good. Yeah.
I sent him an email and.
Oh, I did not. I forgot to do
Yeah.
that.
Should I stand here? Oh, should I stand here before you get to your meeting?
Sure. Go ahead. I really don't mind, because it's stuff like this that I usually forget. There's no excuse. I just keep forgetting. This is tutorial. Download this file. Use phrase 1 and is finished. Only use open office.
I only got a semester here.
Okay, there we go. upload that one file. Today is the 18th, so last week is the 11th.
Yeah, I was trying to find it. Oops.
Upload. This. And we'll give it like 50 points. It's due next week at 8 p.m.
I have class until like 2:50. So I missed the game.
Uncategorized at this point, save and display, save and return. Okay, so the assignment is up. Now it is time to upload the notes. Notes. Come on, where is it? Okay, we have to go to my home folder. And you mentioned it was the 11th?
Yeah.
Okay, so compress. And also the one for today, which is 18. Compress. Now I have to go back to Moodle and actually upload it.
Did you stop recording?
No, recorder is still